Welcome back to Networking Basics, and today we're going to talk about a further subject in this subject area, which refers to network media and interface cards, which are the direct places of physical connection for connectivity in a computerized environment. So when we talk about networking basics, we need to understand things to do with network media. And we mean the physical side of the network, of course, and we are referring to the physical layer of the OSI model that we've been talking about in the last few videos. This is where the digital signals are moving. This is where they're traveling through. They are encoded in a special way so that the computer can read and understand these digital signals. There are also topologies that we're going to talk about that will have to do with how these um, physical connections are actually laid out in a land environment. There's lots of terminology here too, and of course I have a list of basic terminology that you need to grasp and have a hold of, again, to be able to be conversant and fluent in this area. Each network will use a transmission medium, whether we're talking about a wire, some kind of cable, fiber, or radio or light waves that are used to transmit data. Network interface cards, NICs, are at each node, and any physical device of any type in a TCP IP network environment is considered or called, referred to as a node. So these NIC cards act as an interface between the network medium, the wire, and the actual computer. You'll see that the terminology has to do a lot with the wires. Attenuation uh, is about the gradual weakening of a signal as it passes through a wire or through the medium. So a copper wire will only be able to handle the power of that signal for so long because the electrical signal will eventually retard due to the resistance of moving through the copper wire. There's bandwidth also, which is a measurement of the data, the amount of data that can be transmitted over a network cable at one time. It's usually expressed in megabits per second. There's also baseband and broadband signaling. Baseband is your digital signaling. Broadband is your analog signaling. And then crosstalk, this is when you have interference that occurs when a network cable picks up a signal from a cable that is right near to it. There's emissions and EMI and impedance, which is a measure of the attenuation in the cables. Impedance is measured in ohms. It's the unit of electrical resistance. There's lots of media types, and you'll see a chart in the lecture that will talk about the different types, and you can get familiar with what they are, like UTP, which is unshielded twisted pair, and STP, which is shielded twisted pair. Also, we've got thick net and thin net, which I mentioned already, and fiber optics, infrared, radio, and of course microwave. And you'll see the different speeds at which the data can be packaged and traveled through these mediums. And you'll find out, of course, about the maximum distance as well. You'll see that microwave is global. Only time microwave has a problem is when the weather is really bad or it has to go through lots of trees and things like that, things. And where it's the terrain is too thick, it's goes in one direction, so it can have interference from that standpoint. The other wires you'll see a lot of times 100 meters is an important number to remember with certain types of wiring. You'll also find that we have category 3, 4, and 5 cabling, and the highest quality is category 5. Cat 5e is an enhanced version that's out there that is used in a lot of Ethernet cabling networks and topologies. Actually, you can call Ethernet a topology if you want to. There is fiber optics too, and fiber optics, you know, travels, the signals are handled by thin glass or clear plastic fibers that are encased in the protective jacket, and these signals are sent through the cable in the form of light. And there are two types of fiber optic cables. There's the single mode, which uses a single wavelength, and the multi-mode, which uses multiple wavelengths in one single cable. So you've got fiber optics, and it's very popular because it's completely invulnerable to EMI, and it has no detectable emissions. So it's very, very prevalent and very popular out there, and we have fiber to the home now, as well as fiber to the curb, to the business, to the corporate center, and everything else. It's all over the place. We have infrared too, wireless infrared networking systems. What they do is use modulated beams of infrared light to transmit data. These types of networks require a line of sight, and it's generally used for short distance, such as networks within buildings or between nearby buildings. So it's not used for any kind of long distance transmissions at all. You'll find that radio is also still around. We have the use of that. The problem with that is it's a common type of wireless network using radio waves. Radio-based networks have a reasonably high bandwidth, but they're very sensitive, though, to EMI and eavesdropping. So it's very easy to pick up these signals and monitor them. We've got microwave in use not only just terrestrially here on the Earth, the line of sight communication, again a short distance. They are vulnerable to interference, like I mentioned, and eavesdropping as well. They're not quite that vulnerable as radio waves are, but microwave is certainly somewhat vulnerable. But satellite is also in use, where we have Microsoft transmissions via a satellite, allowing for a nearly complete global transmission. The bandwidth can be as high as 10 megabits per second, but the satellite relays do cause delays that may impair real-time communications. I mentioned the network cards earlier, and get a little bit more familiar with them by reading the material, the lecture material in print, and you'll find out about interrupts and I/O addresses and high memory addresses, as well as DMA channels. Interrupts are the available lines used by hardware to notify the processor when data is being transmitted or received. The PC interrupts are numbered in 0 through 15. These are IRQs, and you may want to look a little bit more into that and find out about it. I/O addressing is an address within the bottom 1 megabit of memory to be used as a communication buffer for the hardware. These are just elements of the NIC card. High memory address is an area of memory above 1 megabit that's usually used when a larger area of memory is needed, and of course the DMA channel. Network cards typically require a single interrupt and an I/O address in low memory to operate very well. Several NICs can be installed in a single computer for connection to different network segments, but this requires more network interrupts and addresses when you do that. But this is a part of being a network administrator, knowing when and how to put these NIC cards in there and how many to have. You can also use a concept called binding to to have multiple networks connections on one NIC. So there's another chart about the network interface card settings to help you understand that in the reading as well. You'll find that there is lots of things going on when it comes to designing a network and putting it together based on the physical limitations of the facility that you're working in too. So you have to look at it from the standpoint of, well, what do I have in terms of space, and how can I best use my space with the devices that I have and serve the needs of my company or my business or this educational institution that I'm working in. As I mentioned, we have these different topologies, and in this case we're talking about how things are laid out, not just physically but structurally and logically in these networks. So we talk about, for example, your use of bus topology. You have a single cable that supports an entire network segment. This cable is the bus, sometimes called the backbone. Nodes are attached to various points along the cable. Depending on the network architecture, nodes may be connected directly to the bus with what is known as T-connectors, or a cable called a drop cable. And it can be connected between the bus and each node. You don't necessarily see that many of these anymore, but they're around and they're practical for some situation. There's the star topology. Here each node is connected with its own cable to a central device, and this is most often a hub. The hub internally connects each node to the other nodes in the network. The star wired network typically uses UTP cable, and Ethernet 10BASE-T is the most common network with a star topology. And again, this one's pretty standard and pretty popular in use today in classrooms, star topologies. Then there's a mesh topology. Provides a lot of fault tolerance through redundant links in this type of network. In this system, each node is connected to every other node with separate cables. Thus, a 3-node network would use 3 cables. A 4-node network would use 8 cables. And a 10-node network would require 45 cables because each system, each device, is connected to each other through a cable. This is pretty obvious, has some obvious disadvantages. The mesh topology requires large amounts of cable, and it makes it very expensive to install and to expand. Mesh topology can use routers to choose the best path for each network transmission, but again, you still got lots of cable. Anytime you have lots of cable, you have lots more management. Another type of topology is hybrid. Hybrid topology is any combination of the above topologies. One common hybrid topology is a star bus, in which several star-wired network segments are interconnected with a bus. This topology is useful in networks where groups of workstations are close together, but several distant groups need to be connected. So another hybrid topology is star ring. Ring itself is really a type of topology which has every node connected to a ring, a single ring. Sometimes it has a redundant ring running on the inside of this type of topology. And FIDI is one of the oldest and well-known fiber ring topologies out there. But again, you have disadvantages and advantages of each type of topology. There are also some other devices that you need to know about that have to do with network media. Repeaters is an example of one. A repeater is used to connect two network segments. Each network architecture has a maximum cable length due to attenuation. So the repeaters extend the length of the network beyond this maximum length before we start having problems with the signal by boosting the signal strength so that it can go further. It's a very simple device, and it just boosts the strength of a signal, and it amplifies it. In other words, is the best way to think of it. And it has amplifiers that are used in networks with analog signaling, and digital signaling repeaters regenerate the digital signal. So they're just two different types, two different ways to keep the signal moving. There's also hubs. I mentioned them. There are about 3 different kinds of hubs. The passive hub, which simply connects the nodes. The active hubs, which actually require power and can actually regenerate signals. And intelligent hubs. They will perform some processing or optimization on the data to make sure that it gets there in good shape. There's also switches. Switches or switching hub is a specialized type of hub for maximizing traffic over network segments. And they're multi-port. A normal hub forwards all of the incoming traffic to each of the ports, whereas a switch will forward each packet to the appropriate port based on its destination MAC address. So that's an important thing to keep in mind. There's bridges. Bridges are used to connect 2 or more network segments. A bridge adds to the capabilities of a repeater by monitoring the MAC address of each packet and filtering packets that don't need to be sent to all the segments. So it reduces some network congestion. And then, of course, you've got routers, which are very intelligent devices. They're similar to bridges in that they connect 2 or more network segments. But what they do is they look at packets very carefully, and they have the ability to form a routing table and to be intelligent about filtering packets in terms of many things, actually, ports and addresses themselves. And they're very involved with the logical network address that we call the IP address. And they're a whole subject in themselves is to study routers. We have static routers and dynamic routers, and they have their own protocols that they run on these routers, like RIP and OSPF, for example, which we will talk about in more detail in a later lecture. So again, network media is very much a part of network basics, and we will continue to be talking about parts of this in similar lectures that will expand on some more complex entities like routers and gateways and so forth as we come to the next lecture. So thanks for listening, and I'll be with you again soon.